In section 2 here, we're going to go through proving trigonometric identities. This will be similar to some of the homework problems from section 1. The only difference is we will have where we're going. The proof itself consists of beginning with one side, making small changes that are easily understood until you get to the other side. Okay? These are going to take some creativity, and so this is the type of thing that I think the more you practice, the better you will do. I only ever make changes to one side. You don't want to be changing both sides. So you just keep doing things from one to another. So let me take example, and we'll start with something and see how we can solve it. So if I take an example that says the tangent of x plus the secant of x, and I try to show that that's equal to the cosine of x over 1 minus the sine of x. Now, my suggestion is that you always want to start with making changes to what is the more difficult side. Okay, and that's in General Strategies on page 456, they say that. And if you can't figure out what to do next, change everything into a function of sine and cosine. What I'm going to do is I'm going to go ahead and try to work with the left side. So I'll change tangent into sine of x over cosine of x. That's using the quotient identity. And secant, using its reciprocal identity, is 1 over cosine of x. A lot of times if we have two separate fractions, we want to have a common denominator. Thankfully, we already do. So I can just call that sine x plus 1 over cosine of x. Now, one of the things that is a challenge here with, there's sometimes better ways to do this, and I'm already thinking, man, I may have started down the wrong path here and should do it a different way, but I'm going to try to continue. But there will definitely be times that you'll think, hey, I made a mistake. I want to cross and start over and see if I can do it better another way. That's okay. Don't erase, because you may decide to pick up from where you left off, or as a grader, I may say the way that you've been doing it is fine. I need to think about where I'm going. I need to have a denominator of 1 minus sine x. And right now, it doesn't look like I'm anywhere close to that. Part of me is encouraged that I have a lot of the same stuff, but I can't just flip. I can't just change the sign. I have to do valid mathematical strategies here. So what should I do next? Let's see. I think I'm going to multiply both the top and the bottom times cosine of x. So if I have cosine x, sine x plus 1 over cosine squared x. I might run out of space and move to the right, but normally I would just do things in one column because I don't want to make changes here. Now, based on the trig identities, I never remember if I say sine squared plus cosine squared equals 1, cosine squared is the same as 1 minus sine squared. So I'm going to use that Pythagorean identity to change this into cosine x sine x plus 1 all over 1 minus sine squared x. So I use that Pythagorean identity, which I had to figure out exactly how to use it, but this is what I would leave it as. This I now see as a difference of two squares. So one of the strategies that they state is, if you can, this is in General Strategies 3, use things that are going to give you a difference of two squares to factor it. So I can change that into cosine x sine of x plus 1. Notice, by the way, that I haven't distributed because I don't want that distributed. But this is the same as 1 plus the sine of x, 1 minus the sine of x. Sine of x plus 1 and 1 plus the sine of x, that is the same thing. So those would cancel, and so I would end up with cosine of x over 1 minus sine x. That was my intention to get there. So I used a bunch of different strategies here. I made changes in terms of sine and cosine. I had a common denominator, so I made it one fraction. Then I used a Pythagorean identity so that I could factor something using a difference of two squares. And then ultimately I canceled something to get where I wanted. I know there are multiple ways of doing this, and this may not have been the best, but it works. And it's like doing a proof in geometry. You may be able to do it in 5 steps, you may take 8 steps. You might be able to do it in 3. But the key is trying to get to the end. One of the other strategies I said at the beginning is making sure that I know where am I going, okay, and doing things. But I think that's a good lead for starting these, and so happy practicing. Do lots of examples. The more you do it, the better you'll get at it. Have fun.